Hey everybody, welcome to Bill Sky, the FORTRAN guy. And today we're going to mess around with FORTRAN conditional statements, if statements, how you make decisions in FORTRAN. And we're going to use Fedora Linux today. There's a new Fedora 41 actually when I recorded this. And we're going to use VMware because I can't get the stupid thing to work on VirtualBox on a Mac. I don't know what's going on. But this is another example. I've been trying to use VirtualBox, but this is another example of VMware being superior to VirtualBox. And it just worked out of the box on VMware. So it was VMware Fusion on the Mac. So anyway, I don't want to get politically into a political discussion about VirtualBox versus VMware, but this is an example where VirtualBox just doesn't cut it. And I've tried everything. I've looked on the internet, can't find any kind of reasonable explanation as to why this is happening. So anyway, this is a good example of why you need to have multiple virtualization systems on your computer. Some things on VMware don't work as well as on VirtualBox and vice versa, but this is another example of why you need to use as many virtualization systems as you can and be aware of them. So again, we're going to mess around with FORTRAN decision making, and we're going to use the Intel compiler today instead of the GFortran, the GNU Fortran compiler, just because. So let's get right to it. All right, so as I said, I'm on Fedora Fortran now, or not Fedora Fortran. I'm on Fedora Linux, and you can do this on Windows if you're. It doesn't matter. I've tested this on all. In fact, the code that we're going to do today, I even tested on GFortran. It all works. It's really great. So I'm going to go ahead and start up a Linux project here on FORTRAN, and I'm going to rename it to, let's say, call it FORTRAN Decisions. And we're going to go into that, and I'm going to go ahead and just edit it using my Genie editor. And this is a brand new Fedora, so there's some things I have to do to get it to work. Okay. Now, remember, before you can build, I'm going to go ahead and I'm going to go to the terminal here, and I'm going to set the path from the document, and I'm going to type make. And if you notice, it doesn't know what IFX is. Remember, you've got to set environment variables on the Intel compiler to get it to work. So the way that you do that is you say source. Now, in my template for FORTRAN, I actually have that there in the source code. And the terminal font may look a little bit weird on this Genie. I'm trying to make that better for you, but we're going to zoom in here. So I'm going to say source opt intel 1 API set vares.sh. So now my Genie terminal is all ready for compiling and then running my Intel project. So I'm going to say make clean just to clean it up, and then I'm going to say make, and there it goes. It ran just fine, and I'm going to run the main, and my program is up and running. So again, we haven't done any decisions yet, but let's go ahead and get started. So I'm going to put a little thing here. I'm going to say let's test some conditions, and I'm doing that just to make sure that when I run the program, I know what this program was meant to do. Now, before we get going, I want to create some variables, because when you make decisions, you need to have the data stored somewhere. We can make decisions based on literals like the number 10 or the number 2. That's boring. Let's go ahead and create some variables. And I'm going to create a variable called int500. Now, I'm going to name these kind of weird, and I'm just going to name them because I want to know what the value is in the variable when I'm constructing the if statement. So there's no question in my mind as to what the value is. So I'm going to put in some pretty silly names here. Okay, so there's a couple of integers. We're also going to be doing a little bit of real. So I'm going to say real 500 equals 500.50. Real 1000 equals 1000.10. Okay, just some data. And I'm going to make a character string. I'm going to make it 18 bytes long. And I'm going to say char1 equals hello. I could have called it char hello. Char2 make capitalization, and I'm going to say char3. Now, I put some strange characters in there because we're going to test how FORTRAN actually compares uppercase and lowercase, and we're going to get into the ASCII table and all that. So, in discussing that. So let's go ahead and do that. So, okay, and I always like to put in comments in my code, especially when I'm learning something new. All right, so let's go ahead and save and build that just to make sure it builds okay. It builds fine, and it runs fine too. I haven't done anything weird. There's been no problems. Okay, so let's do our first if statement. So I'm going to call this number 2. A simple if statement. And we're going to decide upon if one variable is greater than or equal to. We're going to do all that right now. So let's go ahead and put in our first if statement. So the format of an if statement in FORTRAN is basically the same as it is in C and C++ and Java. You say if, and then within the parentheses you put the condition that you're checking for, and if the result of that condition is true, if the result of that question is true, you have a then where you do something. I'm going to put in some pseudocode there. And then we say end if at the end. So that's how you do it. Now there is no such thing as an open and close brace, at least for conditions in FORTRAN. You simply say if condition, then do something, and then the end if says what it is, or it says that's the end of the if statement. Don't be checking anymore. Compiler, don't be checking anymore. So let's go ahead and put a condition in there. I'm going to say if int 500, and now this is where it gets kind of weird, .eq dot int 1000. Now, the benefit of naming my variables int 500 and int 1000, you can see, you already know that the int 500 has a value of 500, the int 1000 has a value of 1000. So we know what those values are. So what we're going to do is, in the true portion, I'm going to say print int 500 is equal to int 1000. So if the condition, if int 500 is equal to int 1000, if those are equal, then I want to do this. I want to say int 500 is equal to int 1000. Now you already know that they're not, right? Because 500 is not equal to 1000. But let's see how that works. Notice nothing printed. Absolutely nothing printed whatsoever. And that is because this part of the code was not executed because 500 is not equal to 1000. So it didn't print out. Let's do another one. I'm going to say if int 500 is greater than int 1000. Print int 500 is greater than int 1000. And we know that 500 is not greater than 1000, but I'm demonstrating how the if statement works. And don't forget to put that end if there. So let's go ahead and save and build this. And neither one of those printed because 500 is not equal to 1000, 500 is not greater than 1000. Okay, let's do a less than. That's .lt. Int 500 is less than int 1000. Now you know what's going to happen, right? If you don't know, oops. So 500 is less than 1000. So let's go ahead and save and build that. And there you go. Int 500 is indeed less than int 1000. Now some of you might be saying, well, I would like to do this from a terminal. I don't want to do this because of the way that terminal font is set up. I don't even know. Genie, can I change the terminal font? Let's see. Let's see if I can change the terminal font. Well, it looks like I might be able to. Let's go down here to I believe that there's a coding variable, or there's a coding font. I don't see it there. Let's use this Carlito regular. That looks pretty good. Let's try that out. Oh, it doesn't look very good at all. So let's go ahead and put that back to what it was. Actually, let's go all the way up to the top. Let's try Roman. Oh, it's getting worse. Yeah, let's caldera. Yeah, it's getting pretty bad. So let's go back down to monospace and monospace regular. Okay, so it's back to where it was. I would like to use the terminal instead. So what I'm going to do is I'm going to go into Documents, FORTRAN Projects. There's my FORTRAN decisions. I'm going to right-click, Open in Console. Again, this is Fedora. Now, if I try to make, so I'm going to make it, I get the same error on the Intel compiler because the terminal within Genie is the only one where those variables are set. So let's run that. Oh, I think it's one API, right? And there you go. So we now have the terminal running. So you can do it under both. You can and you can do them alongside each other. Okay. So there you go. So that's the equal, the less than, and the greater than. Let's do another condition. I'm going to say if int 500 is not equal to, that's a dot any dot, int 1000, then print int 500 is not equal to int 1000. Let's go ahead and save and build this. I'm going to do it from the terminal this time. And you can see that int 500 is less than int 1000 and int 500 is not equal to int 1000. So that makes complete sense to me, right? Because 500 is less than 1000 and 500 is not equal to 1000. So those if statements work great. Now, some of you that may be somewhat aware or you've already played around with FORTRAN a bit, you might be asking, why am I using these things? Why am I using the .eq? Well, there's a reason for that. It's because there's a lot of old FORTRAN code out there. And because there are other conditional operators. Like, for instance, instead of .eq, so .eq is the same as double equals. Greater than .gt is the same as greater than. Less than is the same as the less than sign. And not equal to, this one's a little bit different. Not equal to is the same. And by the way, that dash greater than, that's just an arrow I'm drawing. It's not an operator that we're going to be using here. So not equal to is equal to is equal to slash equals. That is not equal to. You've got other operations. We've got greater than or equal to. That's the same as greater than or equal to. A lot of these are a lot like C, C++, and Java. Another one, less than equal to. That's the same as less than equal to. So those are pretty much all of the operators. We've got equals to, we've got greater than, less than. I actually like using these just because FORTRAN was the first high-level language I ever learned in 1976. I just like using them. I don't know why. There's not that many more keystrokes, and it's just kind of, that's how FORTRAN was built. And I like using the legacy stuff. So those are all the different operators that you can use, all the different conditional operators that you can use. Now also, when I'm testing or when I'm writing this code, I also like to put in a print here. I'm going to say this is testing simple conditions. And that's just so I can see better what the output is going to be, or what the output is. So you can see that I'm in the testing simple conditions. I would also like my thing right here to be, I'd like a space below. So I'm going to say a new line. And so now I have a space between that and the conditions and my program ending. Okay. So what else can we do here? Well, with an if statement, just like in other languages, I can put multiple lines of code. I can say print so I can put as many lines of code as I want here. I can put 1, 2, 5, 20, 500. Whatever is located before the end if, that is part of the true condition of my if statement. So let's go ahead and make it. And you can see this is a multi-line true result of an if statement. And that was printed as well. So if this is true, or if any condition is true, anything after the end up to the end if is executed because that result of that condition was true. Okay, so that is our simple format of a condition. Now let's try this. Let's try a thing called an else. So if the result of an if statement is not true, if it is not yes, that question is valid, or that question results in a positive result, a true result, I would like to do something if it's a false result. So I'm going to say print, testing the else statement, just so I can separate my testing code. I'm going to say if int 500 is equal to int 1000, then print int 500. I could copy and paste that. Else, notice I haven't put an end if there yet, else print is not equal to int 1000. And now I put the end if. So the way the compiler does this is it doesn't have open and close braces like C, C++, and Java would, or indents like, I don't even need these indents. I've seen a lot of FORTRAN code without indents. I'm putting the indents there so people that look at my code after I'm done with it don't think I'm an idiot. They don't think I'm a moron. So it makes the code much easier to read. So everything under the then up to the else is executed if this condition is true. Everything after the else up to the end if is executed if this condition is false. And in this case, int 500 is not equal to int 1000, so this code is going to be ignored, and everything inside of the else is going to be executed. So let's go ahead and build that. Let's run it. And you can see that I'm testing the else statement, and int 500 is not equal to int 1000. And we can do it down here as well. And it might be a little bit easier to read because of this font. Int 500 is not equal to int 1000. And you can do that with every operator. If int 500 is greater than int 1000, then, and I'm just going to copy and paste some stuff here. I probably could have copied and pasted the end if as well. Is greater than. And let's see how that works. And there you go. So I'm testing the else statement. Int 500 is not equal to int 1000. Int 500 is not greater than. Should have left off the 2. Greater than int 1000. So that's the else statement. So pretty simple. And if you've got any kind of experience with other languages, this should not be new to you. The new thing is the end if and the open and close brace. Now we can also do multiple lines of code in the else, just like we did in the end, or in the then portion. And by the way, these other lines of code, or any line, it doesn't have to be a print. It can be a calculation. It can be a call to a function. Functions. We're going to do that pretty soon. I actually have that video being scripted right now. I'm working on that. But so I can do that. I can have multiple lines in the then and the else. So you can mix and match. You can do whatever you want. I can even put an if statement in here. Now we're going to get to what we call nested if statements in a little while. So let's go ahead and save and build that. And you can say else second line of code right there. So again, you can have as many lines of code within each one. The special thing to remember is there really is no block of code. There's just, well, there is, but it's not with an open and closed brace of any time or with tabs. It's within the then block before the else, or it's in the else block before the end if. Okay. Now let's take a look at another one. We're going to do a thing called else if now. So let's go ahead and print something out here. Just so I can keep track of what it looks like on my screen. Okay, so I'm going to say if int 500 is equal to int 1000. Then I'm going to say print int 500 is equal to int 1000. And we know that's never going to happen, but we're testing our if statements. So if it's not equal to 1000, I could put another if statement there with an end if I'd like, but I'm not going to do that. I'm going to say else if int 500 is greater than int 1000, then, and let's just go ahead and copy that. So you kind of have one large if statement with a bunch of ifs that ask additional questions. If it's less than, and I could do this again. And what else do I want to do? I guess that's good. And then I'm going to say else. We have a closing else. It's always good to have a closing else. Else, print. I'm going to say I don't know. And then we have an end if at the end. So you might look at this and say, well, this is a little bit confusing. Actually, this is much less confusing than doing it this way. I could create a nested if. So to do the else if with a nested if, I would have to do something like this. Okay, so that is what we call a nested if. I have ifs inside of elses. But then you've got to do this. You've got to say end if. Okay, we need an end if there. We need an end if there. And then an end if there. Wow, so what do you like? Do you like that or do you like that? Now, these basically do the exact same thing. And you can see that it says else if kind of here, but we're not using the else if construct like we're using here. So this is a nested, so the else if is kind of nested, but it's much more readable in my opinion. Now, again, so very, very key thing I just said there, my opinion. And if you don't like the else if you like this, else with a nested if, that's fine. It works great. But you've got a lot more end ifs there. And let's see if this will actually compile. Yep, it actually compiled. And the result is exactly the same. So int 500 is less than 1000, int 1000, it printed twice because we did this right after the first one. So again, it's all part of style. Now, wherever you're working, they may require you to use nested ifs, or they may require you to use else ifs. You need to look at the programmer's standardization guide for the place where you're working. So those are nested ifs within an else. Now, the thing about this is that int 500 is not equal to an int 1000, and int 500 is not equal to int 1000. So when I do this one, it's not going to do this line of code. It's going to now ask this question. If that's not true, it's then going to ask this question. And because int 500 is less than int 1000, it's going to execute this line of code, and then it goes below the end if. It never gets to here. So when you're using else ifs, you might want to take a look at it and be a little creative, a little logical. Does it make any sense? Now, the reason why I have this else down here, if it's not equal to, if it's not greater than, if it's not less than, if it's not equal, there's something happened in your logic. There's a problem. And I always like to close off all of my nested ifs and all of my else if blocks with an else, because it is possible something strange could happen. I don't know. A cosmic ray might hit your chip and might cause a bit to go off, and then your program isn't working correctly. You might laugh at that statement, but that is actually possible. However, very, very improbable. It is possible. So I always liked, and my entire career has always been to complete my if statements with an else. So you finish your code. Your code is mathematically provable that it's complete. We used to call that structured coding back in my day. But these are nested ifs within the else of an if. You can also do nested ifs. So I'm going to say print, and I think we're on 5. Nested if statements. Let's do a nested if statement. And now we already did one up here with an else, but you can also do it within the if. So I'm going to say if int 500 is less than int 1000, then I can put an if here. If real 500 is less than real 1000, then, oh, forgot to close parenthesis, print both conditions are true, else print real 500 is less than real 1000, but int 500, oh, I should say and, oh wait, no, I said that wrong, is not less than. See how the logic can mess you up? But int 500 is less than int 1000. Now, as I said earlier, I could end it right here. I could say end if, and then I could say end if. The problem is I haven't completed this if statement. And is it really necessary? In this case, I think it always is. Else print int 500 is not less than int 1000. And now we've got a complete if statement there. So let's go ahead and build it and run it. And you can see, nested if testing, both conditions are true. Because int 500 is less than int 1000, and real 500 is less than real 1000. Also, something else I want to show you, notice how I'm comparing integers to integers and I'm comparing reals to reals. Very important to do that. You never want to compare an integer with a real or a real with an integer, because integers are completely differently implemented in the CPU than floating point, than real. And I'll put a link to my assembly language video that talks about that, how that actually is implemented, so you can take a look. But it's never good to mix those. And now you might be forced to, but you could get really unpredictable results. Okay, now let's take a look at logical operators. So I'm going to say print 6 logical operator testing. And what is a logical operator? Well, a logical operator is like and, or, not. And in the case of FORTRAN, we have equivalent. And equivalent is used to compare logical things like true or false. So I don't know if we're going to do that in this video. We'll see as we move along. But what these allow you to do is it allows you to ask 2 questions in a single if statement. And let's take a look at what that is. So I'm going to say if int 500, let's name it correctly, if int 500 is less than int 1000 and real 500 is less than real 1000, then, and I want to do something here, I just want to print out a simple little little condition or little result, both left, what do I want to hear? Both left and right conditions are true. Now, what does that mean? An AND means that both conditions, in the case of int 500 and int 1000, that must be true, and real 500 and real 1000 must also be true for the AND to be true, for the entire condition to be true. So if they're both less than, that will be executed. Else, print. Now here's where it gets a little iffy, excuse the pun. We don't know which one is false. We don't know if they're both false, or if the left one is false or the right one is false in the AND condition. So that's why I'm not really crazy about logical operators, because you don't have the detail that you might need in your code to really know which one. I mean, for instance, let's say if this one was false and you need to do something different than if this one is false. By using the AND in the else, you don't know which one is false. You don't know. In this case, nested ifs can be very, very useful for that. Even else ifs can be very, very useful for that. But in this case, I don't know. I don't know. So I have to say either the left or the right condition is false. So it's kind of more general. You're not really sure which one is true. And in this case, both left and right conditions are true. Let's change these to greater than. Let's change that first one to greater than. Let's save and build it. Okay, either the left or the right conversion or condition is false. We don't know. It just is the case that the AND as a whole is false. So you could do something like this. You could say if int 500 is greater than int 1000, then print, the left is false. Else, we could do an if. You see, it's starting to get very, very complicated. So you might not want to use AND as often. It depends. It depends upon, do you really need to know which one was false, the left and the right? Let's say you're writing an if statement that says if they're under 18 and they're not in school, they shouldn't get a job interview. I don't know. You don't care which one is false. If they're both false, they don't get it. So again, it depends upon your code. You just have to decide which one. So that's the AND. Now let's talk about the OR. So I'm going to say if int 500 is greater than int 1000, or real 500 is equal to, or is less than, real 1000. So what's going to happen here with the OR? Well, the OR means if the left or the right are true, the entire thing is true. So I'm going to say print. And again, you're not sure which one is true when the program runs. I mean, we can tell by our code because we named our variables this way. But if the user entered that data, you would know. Your code would know. So I'm going to say either the left or the right are true. Else, I'm going to say print both the left and the right are false. And then let's end our if. So what did I write here? Let's put a space here so we can see a little bit closer. If int 500 is greater than int 1000, which we know is false, or real 500 is less than real 1000, which we know is true, because an OR works that if either side is true, the entire thing is true, this should print. Either the left or right are true. We're not really sure which one it is. Again, I said it earlier. We know in this case because we named our variables this way, but if the user entered data that went into the variable, or we got the data from a file that we put in the variable, we wouldn't know. Our code wouldn't know. So we don't know which one is true or which one is false. We just know that either one of them is true. If both of them are false, if real 500 was not less than real 1000, then the else would be executed. So let's try that. either the left or the right are true. So that was that. We might want to put a print there that we're checking or there. Okay, so that is and or. Let's take a look at not. Now, not can be a little bit confusing. So I'm going to say if not int 500 is greater than int 1000, then print, oh, what is he talking about? Since int 500 is less than int 1000, the not is true. Holy Moses, what's he talking about? Else, I'm just going to put strange. Okay, so what am I talking about here? So because in my if statement, in the condition, I actually have parentheses, what it's going to do, and this is a very, very, very good way of coding. Some people might argue with me because I've got too much stuff going on, or I've got too many parentheses in there. To me, it makes it more understandable. Because when you're doing a condition, it's the same as when you're doing a mathematical computation, is it does parentheses first. Whatever you have in parentheses first, or whatever you have in parentheses is executed first. And in this case, I have this condition. So what is that condition going to return? Is int 500 greater than int 1000? The return of that, the result of that is going to be false. Because 500 is not greater than 1000. So that condition is returned false. What is the not going to do? It's going to flip the false to a true. That's all the not does. It just flips the false to the true, or it flips the true to the false. So because this is false, the not is going to flip it to a true, so that's going to print out. Now, if I put 1000 is greater, well, let's try that. Let's go ahead and make that and make sure. So it did it. So it flipped the false to a true. Now let's take this, copy it, and instead of greater than, let's change this to less than, and let's see what happens. It prints strange on that second if statement, and that's because int 500 is less than int 1000. 500 is less than 1000, so that's going to be a true. What is the not going to do? It's going to convert that true to a false. It's going to flip it, and then we're going to hit the else. So it prints strange. So yeah, not is a negative logic. I love coding with nots, but people that looked at my code said, what the heck was your problem coding that way? It is very difficult for some people to think in negative logic. So you do what you need to do to be a popular, effective programmer. Okay, so let's go ahead and let's do another one. Let's do 7. Let's say comparing strings. So what we're going to do now is we're going to compare strings. So let's go ahead and say if char2 is equal to char3. Now this is why I really like when I'm testing out stuff, I really like to name my variables what the contents is. I'm not sure what those variable values are. So let's go up here and take a look. Okay, char2 is equal to hello, and char3, I don't want to do that one. Let's do this one first. If char1 is equal to char2, let's do that one first. And let's go back up and take a look at what char1 and char2 are. Well, char1 is hello with lowercase ello, and char2 is hello with all uppercase. Okay, so let's take a look at what that's going to do. So if char1 is equal to char2, then print the two strings are equal. Else print the two strings are not equal. Now you might say to yourself, well, these are equal. They both say hello. But that's not how it works. You might also think to yourself, well, char1 is obviously less than char2 because char2 is all capitalized letters and char1 is not. You'd be wrong there too, and we're going to see why. So let's go ahead and make this. Oh, what just happened? Oh, I forgot a close parenthesis. Thank you, compiler, for finding my problem. Okay, the two strings are not equal. So char1 is not equal to char2 because lowercase and uppercase are different. Let's go ahead and see why. I'm going to bring up my browser, and I'm going to go to this website called ASCIItable.com. And the way that comparisons, and this is with just about any programming language. In fact, I have never found a programming language that doesn't do it this way. ASCIItable.com will show you the actual numeric values of every letter in the ASCII table. And ASCII is the format that the computer uses to store letters. So let's take a look at the lowercase and the uppercase e. So we got to find it here. So the uppercase e right here has a value of 69. Now that's the decimal, right? So the uppercase e has a value, or the uppercase e has a value of 69. What does the lowercase e have a value? It has a value of 101. So that means that if I were to compare uppercase with lowercase, the uppercase would always be less than the lowercase. And if you've got multiple, that just increases it. So what happens here? During the comparison, the compiler, the program, will go one letter at a time. So is H in char1 equal to H in char2? Yes, because they're both uppercase H's. They both have the same value, 69, numeric value 69. So they're great. What about the lowercase e? The lowercase e, is lowercase e equal to uppercase e? Nope, because uppercase e has a value, actually I think H is like 72, but the uppercase e is 69. The lowercase e is not 69. It's greater than 69. So that's where the comparison stops immediately on an equality check. Let's do a greater than or equal to check. Or greater than check. So is char1 greater than char2? The left is greater than the right. Left is not greater than the right. Let's see how this one works out. The left is greater than the right. And now why is that? Because lowercase letters have a greater numeric value than uppercase letters. And the way that the condition works, or the way that checking works, is it checks the first character. They're equal, so H is not greater than H. Uppercase H is not greater than H. Lowercase e is greater than uppercase e, and then the checking stops there because the two strings are greater than. Even if I had all Z's there, Z's are all greater than LLO numerically, but because we've got this guy right here, and that is greater than this one, the char1 is always greater than char2 in this case. Okay, that's how those conditions work, and it works for any kind of a character string. What if they were different lengths? So what if this was hello space there? Would the right be greater than the left? No, the left is still greater than the right because you're not comparing the number of characters in a string, you're comparing the characters one character at a time based on that ASCII table. And again, that ASCII table is at ASCIItable.com. All right. One other thing I wanted to mention, I already talked about, you don't want to compare mixed data types. We talked about that earlier. You don't want to compare integers with reals or reals with integers. You also don't want to compare reals or integers with strings. So if I said something like if char1 is equal to int 100 or 1000, then, and I'm just going to say print hello, else print goodbye. Again, ridiculous things, but will that even compile? Let's build that. And the compiler is not allowing me to do this. Let's make sure I'm on the right line of code, 140. Yep. So the compiler is not allowing me to do it. It's not allowing me to compare characters and integers. Same thing if I put real1 I don't think I have real 1. I have real 500, right? Oh, no. Well, hold on. Yeah, I want to do real 500 here. So I'm just showing you how even reals you can't do that. And sometimes the error from the compiler is a little bit nebulous, so you have to kind of look at the code. We're looking at line 140. You can see it right there. And we know that this is the problem. And when we look at it, you just can't compare characters with real or characters with integers or vice versa. Now you can compare integers with reals or reals with integers. It's not recommended. Again, take a look at that floating point assembler language video I'm going to put in the link in the description of this video. Alrighty, so that is conditional processing in FORTRAN. Introduction to it. We simply did ifs, we did if-elses, we did else-ifs, we did nested ifs. We talked about integers, reals, we talked about characters, we talked about the ASCII table. Got a lot done in this video. The next video we're going to do is we're going to talk about loops in FORTRAN. I really hope to see you there.